Okay, in this video, we are going to discuss about the voltage and the current values of the sine wave or the AC signal. Now, in regards to AC signal, we have different terminologies. The first one is we have instantaneous values. Now, if you consider the waveform given here, the sine wave here, at any given time, if you try to find the value of the that waveform, you can have at least some values. For example, at 0 degree, your value is 0, or at somewhere at 45 degree, you have the voltage V2, and then somewhere at 90 degree, we have voltage V1. So the instantaneous value means at any given time, it has some magnitudes. Here we have magnitude V2, V1, and then 0 at the 0 degree, which means at any time we have some magnitude. And that magnitude at given time is called the instantaneous values. And then let's see the second terminology here. We have the peak value. The peak value of the sine wave or the AC signal is the maximum value of the wave during each positive half or the negative half cycle. Now remember that in a complete AC signal, you will have two peak values. One is positive peak value and other one is negative peak value. And if you try to find the average of this positive and negative, we should get 0. Now let me show you which one is the peak value in this waveform here. So as per the definition, it says that the sine wave which has the maximum value at a given time, which means at 90 degree, we have the maximum magnitude. Now this one is positive peak value, and then again at 270 degree here, we have maximum negative peak value. So this, the maximum value is called the peak value. So remember, we will have two peak values, the positive peak value and then the negative peak value. Okay, here we have I have shown you the positive peak value, and then this one is negative peak value. Okay, now the third terminology that we are going to see is peak to peak value. Now, if you measure the distance from the positive peak to the negative peak, then you will get certain amount of the magnitude. That one is called the peak to peak value. For example, now in this waveform here at 90 degree, here we have the positive peak. This is one of the peak value. So peak value is represented by the Vp, V subscript P, and then again at the negative, we have negative side, again we have one Vp here. So if we try to measure the distance from negative peak to the positive peak, then you will have Vpp, which means it's the peak to peak value. The peak to peak value of the sine wave is the maximum value of positive half to the maximum value of the negative half, which means we are measuring from the positive half to the negative half. And then it's given by 2 times the V peak. And then the another terminology that we have with the AC signal is we have the average value. The average value of the curve is the total area under the complete curve divided by the distance of the curve. Now let's consider the waveform here. If you're considering this waveform and then try to find out the average value for this waveform, then we have to find the area under this curve. Then only you'll get the average value. Now in order to find the average value, we are always taking only 1/2 cycle. If you take the complete cycle and then try to find the average value, then you will get 0. See here, if you try to find the average value for this part, and then if we add with this part, you will have 0. The reason is here you have Vp minus Vp, which means the average value you will get 0. Now in order to find the average value for the AC signal, we have to consider only half cycle. Either we have to take it from here to 0 to 180 or from 180 to 360 degree. Or you can just take that 0 to t or t to 2t. We're going to take only half cycle and then try to calculate the average value. The average value of the sine wave is defined over the half cycle period. Average value of the sine wave is the total area under the half cycle curve divided by the distance of the curve. Now distance here, it is either 0 to pi or 0 to 180 or 0 to t. So this is the distance that we are going to consider. And then, okay, now to calculate the average value here, we have V average given by 1 by the distance covered. Now here we are writing in the time domain t here, and then integrating. Now in order to find the area, the same as we have to integrate. Then if we are going to find the if you're going to find the individual values, then we may have to differentiate the signals. But in this case, we're going to find the average, so which means we're going to integrate the signal here. So to integrate this one is 1 divided by the distance covered. Okay, let's continue with this one. Here to find the average value, we have to integrate from the lower limit from starting point, the 0 second, to the half cycle t, and then the signal v of t with respect to time, and then again we have to divide it with the distance it has covered. Now here in this case, to find the average value, we have to take only half cycle. If you take full cycle, your average value will get 0. So in order to avoid that one, we have to take half cycle here, and then distance cover is t. Now this is in the in degree form here. Now here we have mentioned it in the time domain. So from here to here it's t, or if you write in the radian, it's pi here. And then if you take this complete cycle, when you reach here, it will be 2t, or it will be 2 pi here. And then if, okay, now they are giving the function, if v of t is equal to vp, the amplitude, then sine of omega t d omega t, then we have, if you are finding the average value, now here we are taking it in the radian form, 1 by pi 0 to pi vp sine omega t, and then we are differentiating with respect to d omega t, and then our final value is 0.637 vp, which means our average value will be 63.7% of the peak voltage. And here is a small exercise. Determine the average value of the cosine wave f of t is equal to cos omega t, where its amplitude was shown in the table given below. Now here, this is the time domain here, time function here in the radian form. It is starting from minus pi by 2, and then it's come on, complete cycle is given, and then amplitudes are, when it is at minus pi by 2, amplitude is 0. When it is 0, amplitude is v peak, and then when time is at pi by 2, your amplitude is 0 again, and then when it is pi, your amplitude is minus v peak, and then when amplitude is 3 pi by 2, it is again 0, which means from this we can get one complete cycle. In order to find the average value, you can either take from here to here or from here to here, and then you can try to calculate. Now this is the cosine function. Our previous example that we derived here is in the sine. And then the another terminology that we are going to cover is the root mean square value, which we also call it as an effective value. Now the root mean square, or the RMS value, is the measure of the heating effect of the wave. Now RMS is indirectly we're calculating the heating effect of the AC wave when the resistor is connected across the DC source. Okay, let's consider this, the first circuit here. The power is dissipated in the form of heat. Now, when the resistor is connected in series with the DC source, this resistor is dissipating the power in the form of heat. A similar resistor is connected across the AC source. Now, this same resistor is connected across the AC source. At same duration, the same amount of heat is produced, which means this RMS of the sine wave is equal to the DC voltage that produces the same heating effect. And then in order to find the RMS value, we have to find the square root of the given function. And then when you solve this one, we are having VRMS is equal to 70.7% of the V peak. So remember that now this is the standard formula that we have. And then here, in order to get this one, we are taking the function V of t is equal to Vp sin omega t. And then when we solve this one, we are getting 70.7% of the V peak. And then in order to find the peak to peak RMS value, it is 2 V peak divided by root 2. So do not get confused with this one. Now this one is VRMS for only one peak voltage. And then if in order to find the peak to peak voltage, peak to peak RMS value, we have 2 V peak divided by root 2. And then the next topic is we have peak factor and the form factor. A peak factor is the ratio of the peak value to the RMS value of the wave. Now the ratio between the V peak to the VRMS is called the peak factor. And then another is we have form factor, the ratio of RMS value to the average value of the wave. So it's given by form factor is given by VRMS to the V average. And then here we have small exercises. A sine wave has the peak value of 25 volts. Calculate VRMS, V peak to peak, and then you have to calculate V average, the crease factor or the peak factor or the form factor. So calculate this one, and then in the next class we're going to discuss about the AC power.